Okay, looking at some day 2 notes. They're talking about a function f is a rule that associates a unique only one output for each input. So we know there can only be, your x's basically can't be repeated, right? You can't have an x going to 2 different y values. Because otherwise, next thing it talks about is vertical line test. It would not pass the vertical line test if you had an x value going to 2 different y values. So basically what we're talking about, like you can't have the point, let's say 2, 3 and 2, -1, right? Because if you thought about it, if you graphed it, 2, 3 would be here, 2, -1 would be here. That's not going to pass our vertical line test. So that would not be a function. So domain is all values of x that satisfy the equation. Range all values of y that satisfy the equation. In general, the domain of a polynomial function will be all reals. You can do that with the R with like the double line. You could say the word all reals. Some of you might be used to saying -infinity to positive infinity. Any of those are fine. The domain of a radical function, we set what's under the radical greater than or equal to 0 unless radical is in denominator, then we set, then I'll say then just greater than 0. If the radical's in the denominator, then we set the thing underneath just greater than 0. So to kind of look at that, here 3x plus 18, oops, whoa, sorry, 3x plus 18, I don't know what's happening. Trying to get rid of this here. All right, I'm just going to come down here. Oh, I don't know why this is doing this. (3x plus 18 greater than or equal to 0). 3x is greater than or equal to -18. X is then greater than or equal to -6. So that would be the domain. X has to be greater than or equal to -6. Next, we would again take the radical, set it greater than or equal to 0. This is a good review from last year. Whenever you had an inequality degree 2 or higher, so that exponent of a 2 means it's a degree 2 polynomial, you had to do something called partitioning the number line. So this is where you made your number line, -3, 3, color those in because that's where it equals 0. And then to find out where it's greater, you'd put your factors in partition. So you'd pick something to the left of -3, like -4. -4 plus 3 is negative. -4 minus 3 is also negative. And since up here we're multiplying those, we're going to say a negative times a negative is a positive. Then we pick something in the middle of -3 and 3, 0, let's say. Plug in 0 here, that's positive. 0 in here is negative, that's overall negative. To the right of 3, let's say 4, positive, positive, positive. So we want to know where this is greater than 0. So that's going to be where my positives are. So I would say my domain here is -infinity to -3, hard bracket, u, and then 3 to infinity. Okay. The next one, since the radical's in the denominator, I would just want greater than. So it's the same exact, thing as the last problem. So just kind of do this very quickly. And since we just want greater than 0, we don't want to count those. It's not equal to. And we already partitioned and knew it was plus, minus, plus. Greater than would be there, here and here, which just simply means the only difference is we are not counting 3 and -3. So soft brackets on those. X squared minus 5 greater than or equal to 0. This is good to look at because this is not factorable, right? So we still need to know, though, where does this thing equal 0? Which is negative radical 5 and positive radical 5. So those would be my critical values that go on the number line. Equal to here means that we are counting those. We're coloring those in. Greater than means we have to partition. So since I can't put factors, I have to put the whole x squared minus 5 on the line. Radical 5, that's a little bit more than 2, I think about 2.2. So if we just go to 3, that would be positive. In between, we'd pick 0, that's negative. And then to the right of radical 5, let's say 3, again, positive. So domain would be -infinity to negative radical 5, hard bracket, and then positive radical 5 to infinity. Find the domain of the rational functions. We need to understand what is happening in the numerator and the denominator, put them together. Okay, so for fractions, if we've just got basically a polynomial over a polynomial, non-radical over non-radical, my domain is going to be all reals except for what makes denominator equal 0. Right, that's going to be the only restriction here. We don't want what makes the denominator equal to 0. Now, if we have option 2, we have a non-radical in the top, but a radical in the denominator. So this is more like saying a polynomial in the top. So polynomial in the top, but a radical in the bottom. We set radical, or we set, I should say, what's under the radical. We set what's under radical, as we saw before, greater than 0. If the radical's in the top, then we set what's under radical greater than or equal to 0. Okay, so for the domains of these, top is a polynomial, bottom is a polynomial. Oh, there is something tricky here, though. So when you have two polynomials, you do have to factor because a review from last year, if there's a common factor on top and bottom, which there is here, that means there's a hole in the graph. So here we know there's a hole at x equal 2, and then there's still a vertical asymptote at x equals 1, because that's still somewhere where the fraction's undefined. So those are the two things that we can't have in the domain, because there's a hole at 2, there's a vertical asymptote at x equals 1. So domain would be all reals except for 1 and 2. So if they're polynomials, you do have to, so I guess I should say that up here. Factor, cancel, look for hole, because there could be a hole. And then also you want to exclude what makes the denominator equal to 0. So what makes denominators equal to 0, and or if you have it, x value of whole. I should say that there. Okay, next one. Numerator is just a polynomial. Denominator is under the radical. So we want to set what's under the radical just greater than 0, since it's in the denominator of the fraction. Dividing by a negative 12. Remember, when you divide by a negative, you have to flip your inequality sign. So that's my domain. X can be anything less than 3. And you could always double check and like put values in and make sure that it makes sense. Okay, radical. We're going to take radicals on the top. So we're going to set it greater than or equal to 0. However, we are going to have to exclude anything that makes the denominator. So I should probably put that here. Exclude what makes denominator equal to 0. So if I solve this, 4x is greater than or equal to negative 16, x is greater than or equal to negative 4. However, let's factor this, 3x, x. I think we want 1 here and 2 here. Remember, you check your outers, 6x, your inners, 1x. You want them to add to the middle, which is 5. So you need a plus 6 and a minus 1. So your domain is going to be that x is greater than or equal to negative 4. However, x cannot be negative 2 or 1/3, right? What would make this 0 is a third. What would make that 0 is negative 2. So we have to then exclude those. Okay, domains and ranges of your basic functions. These are things you should really know from last year. Like you should know this is a parabola, right? If you needed to do a sketch, you could do a little sketch. Domain is all reals. Range is hard bracket 0 to infinity. Or you could say y greater than or equal to 0. Your cubic function looks like this. So domain is all reals, range is all reals. Square root function starts at 0, 0, jets out like that, right? You know you can't have negatives under square root. So domain is going to be hard bracket 0 to infinity, so is the range. Can't put negative values in for x, you're not going to get a negative value for y. Absolute value is your V looking shape. Domain, all reals. Range, hard bracket 0 to infinity. Cubic root. That's the one, kind of looks out like a kind of stretched out S. So domain is all reals, so is the range. 1 over x, that is your reciprocal function. Looks somewhat like this. Domain and range are all reals except for 0. This has a vertical asymptote at x equals 0 and a horizontal at y equals 0. 1 over x squared, let's say you didn't know what that looks like. You could always think of just putting in x values. Let's say I put in x is 0. Well, then that's undefined. So I know x cannot be 0. I know I have a vertical asymptote. If I put in 1, I get the point 1, 1. If I put in 2, I get a fourth. If I put in 3, I get a ninth. So this is kind of going like this here. Now, let's say I put in negatives. If I put in -1, well, since I'm squaring it, I'm still going to get a positive 1. Same thing, if I put in -2, I'm going to get positive a fourth, positive a ninth. So it looks like that. So if you don't know what it looks like off the top of your head, you just, pick some values of x and spit out some values of y. All reals except 0 for the domain, and the range is going to be what? Soft bracket 0 to infinity. We're never going to hit 0, right? Nothing is going to make this equal to 0 because the numerator is 1. So that would be what that would look like. Again, if you put values in for this one, you'd see it just kind of looks like this. So domain, soft bracket 0 to infinity, range, soft bracket 0 to infinity. Your sine curve starts at 0, goes up, down, up, and just keeps going infinitely like that. So domain is all reals, and the range bounces between -1 and 1. Your cos curve it looks like that. So domain, all reals, range, again, -1 to 1. Now your tan graph has, a pi over 2 has an asymptote. In the middle here is where you're down at -1. The middle here, you're up at +1. And it basically continues the same way in the negative direction. So your domain is all reals except for plus or minus pi over 2, comma, plus or minus 3 pi over 2. Last year, we used to say a lot, tangents undefined at the over 2's. And the range is all reals. This continues, infinitely. This next one is interesting to look at. This one kind of comes up a lot. Let's think about if we put 0 in for x. That's not going to work, right? We'd have 0 over 0. You can't have 0 in the denominator. So we know there's no values at 0. You could think about it. What if you put 1 in? Well, this would be 1 over 1, which is 1. What if you put 2 in? This would be 2 over 2, which is 1. What if you put 3 in? 3 over 3, which is 1. So anything positive, you're going to be up at 1, except at 0, right? You can't have, it's never going to be, x can't be 0. If you put negatives in, so if you think about it, if you put a -1 in, it's the absolute value of -1 over -1, which is 1 over -1 or -1. So when you put -1 in, you're going to get -1. Same thing if you put -2. If you think about it, -2 over -2, this is 2 over -2, which is -1. Same thing's going to happen. So this is just down here. So domain, all reals except for 0. Range can only be -1 and 1. Maybe I shouldn't use a plus sign. -1 and 1. All right, last little bit we're going to talk about, you should know all your transformations from last year. So if there's a negative in front of the A, that's a reflect over x-axis. The value of A tells us if there's a vertical stretch, if the absolute value of A is greater than 1, and there is something called a vertical shrink if the absolute value of A is between 0 and 1. So like a half, a third, it actually compresses it, it vertically shrinks it. B being negative, so inside the parentheses, that's a reflect over the Y. If you think about it, that means the X is negated. If X is negated, it's a reflect over the Y. B tells us if there's a horizontal stretch, if the absolute value of B is between 0 and 1, or horizontal shrink if the absolute value B is greater than 1. The C inside the parenthesis, the plus or minus in the parentheses with the X is your right or left shift. So it's a horizontal shift, and a plus C is left C units, and minus C is right C units. That's the one that's always kind of backwards of how we would think of it. The plus inside the parentheses is actually a left, and a minus is a right. And then the D is your vertical shift, and plus D is right D units, and minus D is down D units. So like for this first one, I would want to know the basic function is square root of x, and then it's shifted up 1. So square root of x, generally jets out from 0, but this is up 1, so it would look like this. So then I should be able to answer without a calculator. Domain is 0 to infinity, hard bracket on the 0. Range is 1 to infinity. This is your reciprocal function, but it's been shifted left 4. So basic function is 1 over x, and then a left 4. So the asymptote goes 1, 2, 3, 4. And then your graph is kind of like that. So your domain, all reals except for -4. Your range, all reals except 0. Because remember, the reciprocal function has a horizontal asymptote at 0. -3 sine x. So this means there's an amplitude of 3 and a reflect over x-axis. So basically what it does is it starts down. Sine normally goes up, but because it's been reflected, it's going to go down. And here's 3, and here's -3. And remember, it does go infinitely. So domain is going to be all reals. range is going to be from -3 to 3 because that's the amplitude. And finally, the last one, if I was thinking of it graphically, I could do, I would want to say, want to factor out the negative. This tells me reflect over y-axis, right 4, up 1. So if I were graphing it, normally jets like this, it's going to reflect right 4 and up 1, and it's reflected over the y. So it would look like that. Domain is -infinity to 4, hard bracket. Range is what? 1 to infinity. You could also, with that one, like you could just set this thing under the radical greater than or equal to 0. So maybe let me show that here. If you took the thing under the radical, set it greater than or equal to 0, you would get that x has to be less than or equal to 4. So that's -infinity to 4. And then you would just have to know this +1 is the up 1. So that's why the range is going from 1 to infinity. So if you didn't remember all those transformations, you could still, get some of these. Like even this one back in letter N, we know we can't have a 0 in the denominator. So that's how we know it's all reals except for -4. But then the range, either you'd have to think of plugging in x values or you would have to think of the graph. All right, that's it for day 2.